The quotient rule for radical is used very often when we're dealing with radicals that are in the numerator and the denominator that have the same index. So the rule is that when you have the same index, so here we have the square root of n, or not the square root, the nth root of a, the nth root of b, that is going to simplify to be the nth root of a over b. So that just says that you can divide the insides when you have a numerator and a denominator in a radical that have the same index. And likewise, when you're given the nth root of a fraction, you can consider the numerator and the denominator separately. That would be the nth root of a divided by the nth root of b. And both come in handy depending on what the problem is. So we're going to look at a few things here. For instance, the first example, the square root of 42x over the square root of 7. The square root of 42 is not perfect. The square root of 7, that is not perfect. But we're going to look at 42 divided by 7, and we see that that's the same thing as the square root of 42x over 7. And 42 over 7 becomes 6. So it allows us to simplify that radical by dividing the numerator divided by the denominator. Now, typically we're going to do this in most cases, not all cases, but in most cases when that denominator goes into the numerator evenly, or when through that division you're going to create something perfect in the denominator. Okay, next example, we've got the cubed root of 54 over the cubed root of 2. The cubed root of 54 over the cubed root of 2. Well, the cubed root of 54 is not perfect. 54 is not a perfect cube. When I think of the cubes, I'm thinking 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. So 54 is not a perfect cube, and neither is 2. However, 54 divided by 2 is going to create something very nice. It's going to create the cubed root of 27, because 54 divided by 2 is 27, and the cubed root of 27 is 3. So you go ahead and try this next problem right here, the square root of 45, 8 to the 11th power, b to the 3rd power, divided by the square root of 5ab, and see what you get. The first thing that you're going to want to consider doing before you hit pause is rewriting this under one radical, because the index in the numerator is the same as the index in the denominator. Press pause, try it, and then come back when you're ready to check your answer. Okay, I'm going to rewrite this 45a to the 11th b cubed over 5ab, and that's the same thing as the square root of 45 divided by 5 is going to be 9. And then we have a to the 11th over a, and that's going to be a to the 10th. And then we have b cubed over b, and b cubed over b is b squared. Now the square root of 9 is 3. The square root of a to the 10th is a to the 5th, and the square root of b squared is b. So that's going to simplify to be 3a to the 5th b. And that's our answer. Okay, this next problem, 81, 16, both underneath a square root. Well, the square root of 81, that's 9. The square root of 16, that's 4. Then we just have to do something with these variables. So x to the 5th over x cubed, and y to the 7th over y to the 5th. So I'm going to rewrite this as the square root of 81 x squared y squared over 16. Now the x squared came from reducing x to the 5th over x cubed, and the y squared came from reducing y to the 7th over y to the 5th. And now we can take the square root of the numerator, which is 9xy, and the square root of the denominator is 4, and we get 9xy over 4. Okay, you try. The only thing different here is that you've got cube roots. So instead of looking for pairs, you're looking for groups of 3. So go ahead and press pause, and then when you're ready to check your answer, come on back. Okay, the cubed root of 27, that's perfect, and the cubed root of 64 is perfect. What's not perfect is the fact that I've got a to the 8th and a to the 2nd power in a fraction. I'm going to simplify those, and I'm also going to simplify b to the 7th over b to the 4th. So that's going to become the cubed root of 27 a to the 6th b cubed over the cubed root of 64. And the cubed root of that numerator is 3a squared b, and the cubed root of the denominator is 4. Okay, we're going to keep going here until we get to the end of these 4 problems, and then we'll make a new video, or the next video. Now, when you read the directions, see what they say. It says divide and simplify. So this one is wanting you to divide first. So it's telling you what it wants you to do. So dividing 60 divided by 3, 40 divided by 5, 144 divided by 2, 32 divided by 2. It's giving you a little bit of a hint, and sometimes the directions are going to do that. So the first thing I'm going to do is I'm going to reduce. I'm going to have the square root of 60 divided by 3 is 20, and then a to the 10th over a cubed is a to the 7th, and then b to the 9th over b to the 9th cancels out. So we've got 20 that we need to break down. So I've got a pair of 2's. So I've got a 2 that comes to the outside, and I'm going to have a 5 left over. Then I've got how many pairs of a's? If I've got 7 a's. If I got 7 a's, I'd get 3 pairs. So that would be a cubed, and I'd have 1 left over. So I'd have the 5 and the a left over. So this 5 is a leftover, goes right there. And then when your index is 2, 2 goes into 7 3 times with 1 left over. And leftovers, they go inside the radical, just like leftovers go in the fridge. Okay, next example, I'm going to divide that 40 over 5, and that's because the square root of 40 is not perfect, the square root of 5 is not perfect. So 40 over 5 becomes an 8 in the numerator, and then we're going to have a to the 5th power, b to the 3rd power. And we don't have anything left over in the denominator. The square root of 8, I've got 8, 2 goes into 8 4 times, 2 goes into 4 2 times. We've got a pair of 2's with 1 left over, so a 2 on the outside and a 2 on the inside. And then we've got the square root of a to the 5th. That's 2 groups of 2 a's with an a left over. And then the square root of b cubed would be 1b on the outside and 1b on the inside. Okay, you go ahead and try the next 2, and I will give you answers as soon as you come back. Okay, the answer to the one on the left, we're just going to give answers here. The answer to the one on the left is 6r cubed s to the 6th times the square root of 2r. And the one on the right is 2ab squared times the 4th root of ab squared. So 2ab squared on the outside, the 4th root of ab squared. Now in the next video, we're going to work with problems like these where it doesn't say to divide first, because dividing first is not going to get us to where we need to be.